So what if I told you that we can actually weigh the world's water from space? Seriously. That we can track every single melting glacier, every major flood, and every devastating drought just by measuring these tiny, tiny shifts in Earth's gravity. It sounds like something straight out of science fiction, right? But it's exactly what we've been doing for more than 2 decades now.
So how in the world do we do it? Well, it's all thanks to a mission called GRACE. That's for Gravity Recovery and Climate Experiment, and its successor, GRACE Follow-On. These are twin satellites, flying one behind the other, and by measuring the minuscule changes in the distance between them, they can map out how mass, and we're mostly talking about water and ice, is moving all around our planet. It's incredible.
For 15 amazing years, GRACE gave us this unprecedented look at our planet's health. But then it went offline. And its replacement wasn't launched for another 11 months, leaving this huge, critical gap in our planet's data record. So what do? How do you fill in the missing pages of Earth's diary?
So how did scientists solve this puzzle? Well, here's how we're going to break it down. First, we'll look at how these twin satellites actually work their magic. Then we'll dig into the problem of that missing data. After that, we'll uncover the brilliant solution they cooked up, see how they put it to the test, and finally, we'll understand why having this complete, unbroken record is so important for all of us. All right, let's dive right in. Before we can really grasp the problem of the missing data, you got to appreciate just what these incredible satellites were doing day in and day out. You can literally think of them as a giant scale in the sky, constantly weighing our planet.
And what GRACE tracks, it's just amazing. We're talking about the fundamental vital signs of planet Earth. Everything from the colossal ice sheets in Greenland and Antarctica to the water that's stored deep underground that we can't even see. This data has completely revolutionized our understanding of the water cycle, climate change, and even the solid Earth beneath our feet.
So everything was going along great, giving us this incredible, continuous movie of our planet. Until it wasn't. The original GRACE mission just couldn't hang on any longer, and it had to be decommissioned before its replacement was ready to take over. So check this out. The first mission ran for 15 years, from 2002 all the way to mid-2017. But its successor, GRACE-FO, didn't launch until May of 2018, and that created an 11-month blind spot, 11 critical months where we were essentially flying blind, completely unable to see what was happening to the planet's water and ice. So why is an 11-month gap such a big deal? Well, as the researchers themselves put it, this break makes it incredibly difficult to study things that are happening continuously. Imagine trying to track a patient's health, but you're missing almost an entire year of their medical charts. You just can't see the full story of how things are changing over time.
But, scientists are a pretty clever bunch. They weren't just about to let an 11-month gap derail 2 decades of absolutely essential research. So they came up with this really sophisticated method to intelligently reconstruct the missing information.
The technique they used is called singular spectrum analysis, or SSA. Now, the easiest way to think about it is like a piece of music. What SSA does is it listens to the rhythm of the data that we do have. It learns the predictable seasonal melody, the wet seasons and the dry seasons, and it learns the steady baseline of those long-term trends. And once it knows the song, it can use that underlying rhythm to fill in the missing notes. So here's how it works in a nutshell. It's kind of like a 3-step process. First, scientists fed the algorithm all the data they had, from both before and after the gap. Second, the algorithm learned the unique rhythm, the unique song, for every single point on the entire globe. And third, it used that knowledge to make a highly educated guess about what must have happened during those 11 missing months. Of course, you can't just go inventing data and call it a day, right? You have to prove that it's actually accurate. So to do that, scientists took their newly completed dataset on a virtual world tour, checking it against what we know really happened on the ground in some of the most dynamic places on Earth.
Okay, first stop, the Amazon basin. This place has one of the most powerful and predictable seasonal pulses on the entire planet, with just massive amounts of water cycling through the ecosystem every year. It's the absolute perfect place to test if the reconstruction got that seasonal rhythm right.
And guess what? It worked beautifully. The method didn't just capture the massive 40-centimeter seasonal swing in water levels. That's the very pulse that acts as the lifeblood for the whole rainforest. It was also sensitive enough to reflect specific events, like the really bad drought they had back in 2016.
Okay, so the method clearly works for these big natural rhythms. But what about long-term changes that are driven by people?
To see how flexible the method was, the scientists then turned their attention to the Indus Basin, a region that is heavily shaped by human activity, especially the long-term depletion of groundwater.
And this, right here, just brilliantly shows the power of this reconstruction. See, in the Indus Basin, the main signal isn't a seasonal pulse. It's a steady, kind of alarming decline in water storage from overexploitation. And the method nailed it. It accurately captured this long-term trend of about minus 1.24 centimeters of water loss per year, a trend that directly threatens water security and the food supply for millions and millions of people.
For our final stop on this tour, we're going to the coldest parts of our planet, Greenland and Antarctica. Now here, tracking the steady loss of ice mass is absolutely vital for understanding and predicting what's going to happen with future sea level rise. Now this tells us something really important about confidence in the data itself. You see, there are a few different scientific teams that process GRACE information, and before this fix, their results for Greenland had some pretty big differences. But after they applied this reconstruction, the disagreement between their models dropped by about 90%. That means the fix didn't just fill the gap, it actually made the entire dataset more robust and more reliable for everybody.
So, scientists bridged an 11-month gap in satellite data. It's a really cool technical achievement for sure, but what's the real-world impact? Why does this actually matter so much?
Well, it means that we now have a seamless, unbroken health record for our planet's water and ice that stretches over 2 full decades. Those missing pages in Earth's diary, they've been restored, creating one continuous, epic story.
And having a complete record like this, it's an absolute game changer. It lets us get a much deeper understanding of extreme events like floods and droughts. It gives us a continuous way to track our planet's fresh water, it sharpens our monitoring of ice melt and sea level rise, and ultimately it provides crucial data that helps us build better, more accurate climate models.
I mean, as the authors of the study themselves said, this continuous dataset is the key to truly understanding the climate events that are shaping our world. It moves us from just looking at a series of snapshots to watching the complete motion picture of a planet in constant change.
By mending this crucial gap in our observations, we've given ourselves a more powerful tool than ever before to monitor our changing world. And it just leaves you with this tantalizing thought. Now that we can finally read the full story without any missing pages, what new secrets is our planet about to reveal?